Hi everyone, I'm Nick, and we are Bottega 8. We are a boutique AI engineering agency. We architect, build, and scale custom AI and machine learning products. Our Bottega 8 motto is very simple. We ship a year's worth of roadmap in a quarter, so you can jumpstart AI innovation.
A lot of people hear AI agency and they think that we're going to come to your organization and teach you how to use ChatGPT. And that is just not what we do. We build AI that scales with you to production while mentoring and coaching your organization towards AI adoption across your tech stack. You get a fully designed and deployed custom AI solution for greenfield innovation, something that can handle serious regulatory data and scaling challenges.
Beyond the tech, we show you how to capitalize on AI for growth, how to package new features, accelerate fundraising, and expand to new markets. We've seen clients increase their ROI up to 4 times within a year by building and deploying AI the right way.
And that's where I come in to help build out the pipelines and the ML ops and the agent workflows. A lot of companies that we work with, they find they don't have the resources in house. They're just too busy on other things, or they don't have the expertise in house. And so that's where we can come in and build it all out and be concerned with the regulation and the compliance that's so important. So that's where we can step in.
Once those foundations are in place, we pick a foundational AI model to build on top of to create something truly bespoke to all of our clients. So, for instance, using Gemini as a base model and then instructing it specifically for a regulated industry. Also, we bring to the table understanding of where the models are going and what's new so that you don't have to be left behind.
Yeah, and with massive financial gains at stake for your company, we want to pop the hood today and show you exactly what it is we do and how we do it. To start, you might be wondering who actually sees the most benefit from implementing AI today? VCs, boards, executives, founders, we have those conversations all the time. And what we see is there's three really clear indicators that set up a company for major greenfield impact. First, they're drowning in complex data. They have multiple sources, high volume, or weird, unique formats. Second, they're eager to transform manual workflows and processes, whether that's for accelerating growth or reinventing their operations to minimize OpEx. Lastly, the third big important indicator is they see the AI writing on the wall. Perhaps they have done some experiments with off-the-shelf LLM tools like OpenAI or Anthropic and seen some early nuggets of hope that they could actually implement something custom, or they see where their industry is going with these tools and need to modernize.
And so this is where we really step in to go beyond what a lot of the off the shelf solutions, where people have tried these things but ran into these hallucinations and other issues. This is where the specifics to the industry and domain are so important. We step in to help handle what are the specific regulations for the given use case, what governance needs to be considered in the specific use case to really tailor the solution to what the problem is that we're solving.
Yeah, and all of those factors really boil down to developing a sophisticated machine learning and AI integration that one by one in your backend pipeline and your data science and data engineering pipeline helps suss out those problems and de-risk them so you can actually ship it to production. So now on to the main event. Today we're unpacking how to turn monster-sized PDFs for proper AI fluency and scalability, plus reducing any errors you may have when you have to process these large documents.
Really, the biggest problem here is that if you just took a PDF and put that into ChatGPT and you ask some questions, you're going to get very generic answers. And if you're working within a context of something that's highly regulated, very specific with domain expertise, we can't just rely on ChatGPT. And matter of fact, that's just not what we do. So instead of wrangling all of this text by popping it into ChatGPT, or even building a very basic RAG solution, What we're doing is something much more robust. So not relying on OCR, but relying on Vision APIs. So in this particular project, we use Gemini 2.5 Vision to go through each PDF's page as the way of understanding things. Because if you just take a PDF and put it into text, you're going to lose a lot of context. You're going to lose information about the table. You'll lose information about footnotes. It just all kind of evaporates. We use another tool called BAML, which is really boundary ML. And this is a structured format of working with foundational models like Gemini. So we're able to look at a page and get very specific pieces of information off of it, such as regulations, laws, people, whatever you could imagine, we can extract. And then from there, we load this into a graph. And the reason why to load it into a graph is to model the relationships, because within a highly regulated industry or any company, there's rules that we have to follow. And I mean, it's really just as simple as that.
This is where we really go beyond what RAG can do. A lot of people have tried that, pushed it as far as it can go, but ultimately there always ends up being some degree of hallucination and a huge gap on the actual regulation and governance side of things.
And we find that many enterprises have this problem across industries. Most content they have is long, unwielding, and siloed. And in the past, this was so difficult to wrangle and use. But now with AI, we've seen significant gains.
A lot of people are using ChatGPT, they're using Claude, they're using Gemini already, and you would copy out of a PDF and put it into there. That's okay, but the issue is that you lose a lot of fidelity. So something showing up in a table format, headers, footers, formatting, all these things are highly visual. They're not text. And when people will take the PDF and turn it into text and use that to do large language model work on, it just ends up losing context and it loses the information.
Even little graphics, for example, an entire table might refer to a graphic or a chart. And if you just use text, you'd lose all of that information. And in, say, a PowerPoint deck or a PDF itself. So it just lends itself to using this approach. And it also sidesteps some specific token quirks, whether the doc is in English or Mandarin. Pixels are pixels, So now let's walk through the pipeline itself.
So here is kind of the visual aid for what Matt just mentioned around how we've broken this down into a pretty sophisticated pipeline so far. And this is really kind of our V1 of this. As you can see up here at the top, this is the graph tier. And, Matt mentioned this is one of the pieces that we use to go beyond what some of these off-the-shelf solutions do to actually prevent the hallucination and be able to manage the risk around compliance and governance. So that just kind of sits above the layer here. But if we look at the box below, we can see what the actual pipeline looks like. And so in this case, we're using AWS for this part of the system. We'll talk more about the cloud architecture here in a minute. But this is the overall document ingestion and processing pipeline. So you can see there's a PDF upload. We just put those documents right into S3. Here's the step that we convert to image for the reasons that Matt just mentioned. So we can make sure we're getting the highest fidelity data. At that point, then we put it into a queue. And then here we are doing multiple passes, multiple prompts to send it to the vision model and then store that and extract all the relevant data with BAML, like Matt just mentioned. So from here, you can see we're calling out to Gemini and we're doing multiple passes. There's lots of prompt engineering that we've had to get right to make this work. But this is kind of the overall view of how the processing pipeline works. So let me just flip my tab over and I can share the cloud architecture here. So for this project, we took a multi-cloud approach, which is a bit different from what we would typically do historically. So we've all got lots of experience helping companies and products go from 0 to 1. And historically, we would only want to focus on one cloud to keep things simple. Most clouds had similar services, and it was just a matter of picking a preference or where your expertise was. But now, in the age of AI, with the state of the art moving so quickly, literally week over week, day over day, the terrain is changing. And so we want to have the maximum flexibility. And some of these models, like Gemini, for example, we have to run that within GCP, in Google's cloud platform. Having a multi-cloud architecture like we have here allows us to have the flexibility to be able to change and always be using the best models at the given time and always stay on the cutting edge of the state of the art. So that's why we chose that a multi-cloud architecture here. And so if we get into kind of how this is actually structured, you can see we've got a continuous integration and continuous delivery pipelines on the right, just as, best practices for good software development. Within the AWS side, you can see the S3 bucket where we're storing the raw PDFs, which we saw on the other diagram. This is the overall workflow of images to queue to actually extracting the data with the Vision API on Gemini, and then storing it all in the graph database with Kuzu.
Yeah, and thanks, Todd. And one of the only things that have been constant in the last 2 years of working in AI is that your technical architecture must be model agnostic. We've learned models come out every other week and they have different strengths and weaknesses. And so being able to have this multi-cloud architecture, which, 10 years ago or 5 years ago, I would be like, no, we would never do that, actually made sense. And as long as you make sure your DevOps and infrastructure deployments are in the same region and some performance tests, you shouldn't see many issues, and we haven't seen any issues when it comes to having a multi-cloud architecture.
Yeah, so Kuzu is just an implementation of a graph database, and what's nice about it is that it's an embedded version of Neo4j or any graph database. Think of it very simply as there are nodes, and then there's relationship between those things. Now, that's really basic, but as you could imagine, if you're working within a specific company, there might be people, organizations, laws, regulations, rules that you have to abide by. And what's nice about a graph is that you can express this in a way that is modeling reality, as opposed to the way that most RAG systems work, the semantic RAG. They're just looking for areas of text that more or less match what you're asking off of. So with Kuzu, with a graph database, we're able to model out the domain, so to speak. And this sets us up for success in a lot of ways. One, it's modeling the territory more accurately and more honestly, as opposed to just scanning for passages within text. And the second thing that it really sets us up for is ChatGPT or any foundational model understands Cypher, which is a language. It's a little bit like SQL, and Cypher is a way of querying a graph database. So you can actually use the foundational model to find the optimal graph query to find exactly what you need when you need it. So if you're asking big questions like, what is the most complicated deployment in my industry right now based off of the data that I have, you can start to ask those kinds of questions and you'll get real answers. The other nice thing is about auditability and governance. A lot of the time in machine learning, which is my background, we'll give an answer and people will say, well, how did you get to that answer? And then the usual answer to that question is, we have no idea how we got to that answer. And with graphs, you can actually show people exactly how we got to that answer, which really increases trust, reliability, honesty, all the things that you would want, especially if you're working in a regulated industry.
Yes, and Kuzu's compression means tens of thousands of documents in just a couple gigs, which is really amazing.
Yeah, so I'm a big fan of Boundary ML, BAML, because it is super powerful. So people have figured this out pretty early with ChatGPT, that you can ask for JSON responses. So you can say, hey, I'm going to take an image, give me some JSON. GPT-4 and Gemini and Claude and all of these different models will do that. But a lot of the time it's wrong, or it's actually embedded in some markdown, or it's really, really messy, or it's just completely made up. What BAML does is really special because we can define a specific type, a type of response that we're trying to get. Let's say that we're modeling regulations and we want to scan a document to find all the laws or legislations. We can define exactly what we're after. We can describe it. We can say that this is a required field and this is an optional field. And this really improves type safety, runtime errors, reliability, and scalability, because we just we know exactly what we're going to get.
Yeah, and here's your allowed fields, and there's the types, and go. So
Yep.
we've given that those guidelines, right?
Yep. Exactly.
Cool. One other thing that I wanted to mention is we have embedded tiny quality checks in the grammar to catch any misordering, pages on uploads. There's all sorts of engineering goodness that we can get from this approach.
The first lesson learned is you can only push one-shot prompts so far. And this is just an extension of the lesson is off-the-shelf stuff you can only push so far for the reason that we approach solutions in the way that we do. And so I think it's kind of amazing how far you can push Gemini, but it's not the ultimate solution to just one-shot everything. I think another key thing is BAML. Matt mentioned how valuable it is. And I think the ability to be able to have such type safety around what we're expecting is so important. And then also the importance of relying on images and not just going straight to text. I think storing the raw images are really key. That allows us to have the fidelity that we spoke about earlier.
Yeah, and from a budget perspective, I'm sure everyone's wondering how much does this cost? You're converting every page of a PDF into singular images, and it's about $0.002 per page, so a fraction of a cent, so 1/5 a cent. That's much cheaper than a lot of OCR integrations, plus regex passes that no engineer likes, right? So we thought this would be a great approach. So yeah, to wrap this up, Matt, what's next up for us and the road ahead?
Yeah. The thing that's on the road ahead is generating and adding to a graph. So we talked in a way about a graph per PDF, so like a big 200-page PDF. And what's on the roadmap for us next with this particular project is moving beyond that into more of how do you connect all of the different entities together. And I think that becomes quite exciting to look into.
If any of this sounds fun and you're interested, we're building. So please DM us, email us, you know how to reach us, and we'll catch you all next time.